This video is about perpendicular bisectors, and perpendicular bisectors are one of those nice things in geometry that tell you exactly what they are. If something is perpendicular, that means it forms 90-degree angles, and if it's a bisector, that means it cuts something in half. So a perpendicular bisector is literally perpendicular lines that cut things in half. As you're doing this, you need to remember all you know about isosceles and equilateral triangles, because that will come in handy. So let's put that as a reminder here. Remember all you know about isosceles and equilateral triangles, but you also want to remember what you know about congruent triangles. Before we even go into the definition, we need to remember what we know about congruent triangles. These two triangles, triangle CDA and triangle CDB, are congruent by side, angle, side. Okay? So the fact that these two triangles are congruent tells us that whatever is in this triangle is going to be equal to this triangle because they're congruent. And congruent, remember, means the same. So if we look at the perpendicular bisector theorem, it states, if a point lies on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So this line right here, CD, is my perpendicular bisector. And it's a perpendicular bisector for two reasons. One, it forms a 90-degree angle. So we know that CD is perpendicular to AB because it has a 90-degree angle. And we know that AD is congruent to BD. And I know that they're congruent because they each have one tick mark. So if this is 90 degrees and the sides are congruent, this theorem tells me that CA is going to be congruent to CB. I can also write it as segment CA is congruent to segment CB. Remember, when there's no symbol, that means the numbers. When there are symbols, that literally means the sides. So again, if this is 90 degrees, this is a perpendicular bisector because it's perpendicular, 90 degrees, and bisects or cuts the side in half. That tells me that the other sides of the triangle are equal. The converse of the perpendicular bisector theorem states, if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. This is saying that C is equidistant from A and B. I know it's equidistant because it's the same length. And I know that it's the same length, remember, because of the tick marks. So this is saying if CA is equal to CB, then a line exists through C so that CD is perpendicular to AB. So that means if these segments are the same, okay, that means that this has to be perpendicular and that AD is going to be equal or congruent to BD. So these are opposites. And what is important to know is that if this is 90 degrees and these segments are the same, then these segments at the bottom will be the same. The reason that we have a theorem and then the converse is because it depends on what the original picture tells you. So if we look at example 1, this is using the perpendicular bisector theorem. How do I know? Well, here's a 90-degree angle, and this segment is bisected. The perpendicular bisector theorem tells me that this segment will be congruent to this segment. And if the segments are congruent, then I simply write the equations equal to each other. So I would have 7x plus 24 equals 13x minus 48. And my question tells me to find x, so I'm just going to solve. I subtract 7x from each side. I get 24 is equal to 6x minus 48. Then I'm going to add 48 to either side. And I get 72 is equal to 6x. I just kind of run out of space. I divide by 6, and x is equal to 12. If I look at question number 2, this is the converse of the perpendicular bisector theorem. I know it's the converse because it's telling me that these segments are congruent up here. Here's my 90-degree angle, and the converse tells me then that these segments at the bottom will be congruent. So I would take 17x minus 3 and make it equal to 9x plus 13. I subtract 9x from both sides, and I get 8x minus 3 is equal to 13. I add 3 to both sides. I get 8x is equal to 16, and x is equal to 2. Now, in this example and the previous example, I am done because the question asks me to find x. However, on examples 3 and 4, you're being asked to find the segment. So that means once you find x, you are going to substitute it back in. Please take a moment and solve question 3. To solve question 3, I see that this is perpendicular and segment QS is bisected. That lets me know that segment RQ is congruent to segment RS. So I will set them equal to each other, and I get 7x minus 22 is equal to 4x plus 5. I subtract 4x from both sides, and I get 3x minus 22 is equal to 5. I'm going to add that 22 to both sides. I get 3x is equal to 27, and therefore x is equal to 9. However, I am looking for RS. So that means I come over here, I see that RS is 4x plus 5, and I substitute. So 4 times 9 plus 5 is 36 plus 5, which is 41. So RS is equal to 41. Please take a moment and find the answer to question 4. So again, these are congruent and this is perpendicular, which tells me that segment EG is congruent to segment GF, or FG, excuse me. So I set these equal to each other. So I get 2x plus 11 is equal to 14x minus 37. I subtract 2x and I get 12x. I add 37 and I get 48 is equal to 12x. And then I divide and I get 4 is equal to x. But again, it's asking me for EG. So I substitute. And 8 plus 11 is 19. So EG is 19. Please solve question 5. So in order to find AB, this is exactly like example 4. I find that my two segments are congruent, which means that these segments are congruent. So I would take 5x minus 11 is equal to 3x plus 17. I subtract 3x and I get 2x minus 11 is equal to 17. Then I add 11, so I get 2x is equal to 28. I divide both sides by 2 and x is 14. Since I want AB, I'm going to look here. Now what I see is that AB is the whole thing. So I have options here. I can substitute into AD into one side, and I get 5 times 14 minus 11. So that is going to be 70 minus 11 is 59. So if I know that this side is 59, then I know that this side is 59, and 59 plus 59 will be 118. So AB is 118. Please take a moment and find the answer to question 6. So question 6 is asking me to find segment JK. So since this is bisected and this is perpendicular, I know this is a perpendicular bisector, which tells me that these sides JK and LK are congruent, and I'm going to continue to do what I've been doing, which is to set these equations equal to each other. 6x minus 26 is equal to 3x plus 34. I subtract 3x from each side. I get 3x minus 26 is equal to 34. Add 26 to both sides, and I get 3x is equal to 60. I divide by 3, and I get x is equal to 20. But again, it's not asking me for x, it's asking me for segment JK, which is right here. So I substitute. 6 times 20 is 120 minus 26 gives me 94, and therefore JK is equal to 94.